In this video, we're going to be talking about how to create a light sensor triggered LED using the Arduino. So we know that we have a photoresistor, which its resistance changes based on whether or not there's light shining on it. So when there's light on, the resistance of the photoresistor is lower. We have an Arduino Nano. Unfortunately, its input pins read voltage signals, not resistance. It can't tell the resistance of a resistor unless we hook it up correctly. So let's talk about how we're going to do that. We will use a couple of things that we've talked about already. We've talked about Ohm's law, and we're going to use Kirchhoff's current law, and we're going to use a device called a voltage divider, or a circuit called a voltage divider. So we have a circuit with a supply voltage and two resistors. And in this example, we know the resistance of these two resistors. We know that the supply voltage, if we were to measure it at this location, would be the 5 volts. We know that if we were to measure the difference between the supply and the ground, that the ground voltage is 0 volts. But we might want to know what the voltage would be measured in between these two circuits. We're going to call that V out. We will use our Ohm's law and our Kirchhoff's current law to figure out what V out is. So Ohm's law, I always remember it as V is equal to IR. So voltage drop across any element of a circuit is equal to the current flowing through that circuit multiplied by the resistance of that element of the circuit or that piece of the circuit. I can rearrange that to solve for current. So current is equal to V over R. And we know that because this is a circuit and there's a single wire connecting the supply voltage to the ground, that the current through the circuit at any point in the circuit or along any piece of the circuit is going to be the same. So I can say that the current across the entire circuit between the supply and the ground is equal to the voltage drop between the supply and the ground divided by the sum of the resistance that is going to be seen between those 2 points. So resistor 1 plus resistor 2. Because the current is the same all the way through, it's also the same across just this resistor. So that the voltage difference V out minus ground, so voltage out is equal to, the current is equal to the voltage out divided by just the resistor 2 across which that voltage drop happens. So I can, because the current's the same, I can equate those two values and then I can use that to solve for V out. So just rearranging, V out is equal to the resistance R2 divided by R1 plus R2 times the voltage supply. So for this example, plugging in the numbers for each of these resistors, we get that the voltage at V out, measured at V out, would be 2.6 volts. If you play around with these different, giving different resistances for R1 and R2, we see that the voltage out depends on the relative values of R1 and R2. So we can use that to our advantage in creating a voltage divider with this photoresistor. So we can measure this voltage out, this is where V out would be, and it will change based on what the resistance is of the photoresistor. So as the light hits the photoresistor or as the photoresistor senses darkness, V out is going to change. If we hook that up to our Arduino, we have an analog out or an analog pin. This is hooked to A0 that we can measure that voltage out. And that's just in between this voltage divider, just like we've shown in this schematic. We'll connect the photoresistor to the 5 volt supply and then measure the difference, measure the voltage in between the two resistors with A0. And then our R2, which is our 10K ohm resistor, gets then connected to the ground pin on the Arduino. So let's see how we would hook that up. So here's a picture of what your circuit should look like so far. We still have our LED connected. The things that have changed, we've now created, instead of just a ground rail like we had before, we've connected this plus rail to the 5-volt supply. So now all along this plus column, we will have a 5-volt supply. So we connect the photoresistor to the 5-volt supply and then to A0, and to create that little junction point or measure in between those two resistors, we can connect the 10K ohm resistor from A0 to ground. And that is it. There's a voltage divider. Let's see how to set that up. Now that we have the physical device and the circuit all hooked up, it's time to write the code so that we can use the sensor to start triggering the LED and turning it on. What you see here is my original program and code for turning on and off an LED that is connected to the Arduino. And it turns it on and off repeatedly. So now we're just going to take this code and modify it to be able to use the functionality of the light sensor. The first thing that we need to do is define a constant for the light sensor so that we know so that Arduino knows which analog pin it's going to be connected to. And I'm going to put that close to where I've defined the color pins, and we'll use the similar language as we did before. So constant and it's integer, and we're going to call this light sensor. And I will tell the computer that it's hooked to analog pin 0, A0. Always remember to end your commands with a semicolon. The next thing that we need to do is shortly thereafter, we need to initialize a variable that we're going to store values that the sensor pulls in on A0. So we have to have a place for it to collect those values and store those values. So we're going to initialize this variable. We have to define what that variable is and give it a value to start with. So I'm going to, since it's not a constant, I want to be able to update this value. It's just an integer, and I'm going to call this variable lightVal. Light. And we'll just initialize it to be 0. It will change as we pull in sensor data. So that's fine. Next thing, we need to be able to see what kind of numbers we get for light and dark values when we're collecting data, or when the Arduino is collecting data. We want to see what those numbers are when we have light and when we have dark. And so we need to be able to see the numbers that it's collecting. We do that by using the serial port. So we need to set up the serial port so that we can start collecting data and displaying data through that serial port. And we do that with the command serial.begin. And this is the baud rate 9600 that we want it to be transmitting data. And that's just serial setup. So once we have that set up, and that's done within the setup function, then we can go into the loop function and start displaying that value. So because this is, I don't really need to have the light blinking on and off, I'm going to do a multi-line comment. then I'm actually going to leave that delay in there because I want to not take data quite so frequently. So we're going to comment out all of this. Now it's all grayed out, all this turning the LED on and off. And I'm instead going to start collecting data. So we'll now use that placeholder variable and give it some information, give it a value. And the value that we give it is what gets read. So analog, what gets read from the light sensor. And since we've already told it that when I say light sensor, that means that I'm going to read from A0, I can just write light sensor there. So the statement says, whatever you read from the light sensor pin, stick that number in light val. So that reads the input pin, and then we're going to be able to display that on the serial. So we type in serial dot print ln, and so it's going to print a line, and the thing that I want it to print is the value of light val, always ending with a semicolon. So this is going to display the reading, and it's going to display it on the serial port. Always adding in comments so that we can then go back and know what each line does. Okay, so instead of turning the light on and off, the loop is just going to every second, because it's going to delay between each reading and print value. It's going to delay the value, or it's going to delay printing that, and it will do that every second. So we can then upload the code to our Arduino. Don't forget to save, and then upload actually saves and uploads it. So if we upload the code to the Arduino, now we can test it and see if it's working like we expect it to. Okay, so in order to be able to see what it's seeing, I have to open the serial monitor. So up here in Tools, I'll select that and then select Serial Monitor, because I'd like to see a number that's being displayed, and it starts, you can see the numbers that are coming in. That's that value between 0 and 1063 that it's displaying. Right now, that means that it's, since it's about 500, the resistance that the photoresistor has is approximately equal, maybe a little less than the resistance of that 10K ohm resistor. But as I cover the resistor with my hand, you can see that that value is going down because that resistance has gone up. When I uncover the sensor, they go back up. So lower values means that it's dark, and it looks like, as I uncover and cover it up, looks like dark is something below about 350. So I'll select that as my threshold value. We'll close this window, the serial monitor. And what we can do now is define a trigger value for what dark means. So I'm going to go back up here, and underneath our initialized variable, I'm going to define a low light level, and this is going to be that level that I observed when I was covering up the sensor. So this one is going to be a constant, and I'll just call that is dark value. And I'm going to set that based on what my sensor was reading at 350. You may find a different value for your sensor. So now that I have that trigger value, whenever I'm going to now add logic so that whenever the sensor senses that value, it will, when it goes below that value, it will say it's dark and turn on the light. So I've got to add some code down into this loop function because I want it to keep doing that over and over again. And I need these pieces of code, so I'll delete this multi-line comment, but I want this to be a conditional. So I want to only turn on the LED if it's dark. So I'm going to use something called an if-else statement. The if statement, let's see, we'll give ourselves another line here. So I say if, and then whatever condition I put in these parentheses is the condition that has to be met for the program to execute what is within the brackets, the curly brackets. So I'm going to say if light val is less than is dark val. So if the light value that gets measured is less than that threshold that I determined that means it's dark, then I'm going to do what is happening between these parentheses. And I want to turn the light on. So I have all this code to turn the light on. I'll just indent this because that's helps me see where all the code gets placed. And then I have to, since I opened the curly braces, I've got to close the curly braces. So if the light val is less than the dark value threshold, then do the stuff that's between this curly brace and this curly brace. And that is the code that we already wrote to turn on the light. Now I want it to do something otherwise, so I'll say else. So for all other conditions, do the stuff that is between this curly brace, and I want it to turn off if it's between this curly brace and the last curly brace. So if the light value is dark, turn the light on, else turn the light off. And then we end that curly brace, and then we're going to wait for a second before we try running the program again. So go ahead and upload this to your Arduino, and we should be able to see that if I have my hand covering the sensor, it turns on. If I move my hand so it senses light, the light turns off. So I can play with that. Again, you can change the color, however you want to do that. You can change the threshold to determine what is dark, but that's a basic code, and we now have a nightlight that will be turned on when it's dark.